Yeah. That should be fine.
Okay, so 32, make that sine of theta equals -1/4.5. And let's see here. That's going to come back as -12.8, which is in quadrant 4. And obviously that's not one of our answers because it has to be between 0 and 360. So that use that as your reference angle. And so you do 360 minus that, you get to 347.2. Sine will also be negative in quadrant 4, or excuse me, 3. And so that one's going to be 180 plus 12.8, and this will be 360 minus 12.8. Okay, for that on those. All right, what was the next one? 55? All right, 55. What'd you get for that one, Cooper?
For 55, I had pi over 4, 5 pi over 4, 7 pi over 6, and 11 pi over 6.
Did you say 5 pi over 4?
I did, but it might have been 3 pi over 4.
Oh, it keeps going. 7 pi over 4.
Oh, I wrote the 4s and 6s in the wrong place.
What?
Well, your 6s were okay. I got pi over 4.
Yeah.
7 pi over 4.
Yeah.
7 pi over 6.
Yeah.
11 pi over 6.
So yeah, I just did one wrong.
All right. Agreed? Good there?
Yeah.
All right, 65. Luke, what do you got back there?
I had pi over 2.
For 65?
Yeah.
Number 65.
Yeah.
Pi over 2?
Yeah.
Okay.
Or, hold on. Maybe that's pi.
Maybe that's pi, Graham? No. No, still trying. Aaron Hess, what'd you have for 65?
I had pi over 3 and 5 pi over 3.
All right. Luke, what did you factor it into?
2 cosine of theta minus 3 and cosine of theta plus 1.
That would be the problem. Because it equals 2 there. So for 65, in that case here, I'm going to write 2 cosine squared theta, and then plus 3 cosine theta. And then I'm going to move the 2 over and make it minus 2. So he's got to multiply to minus 2. 2 cosine theta, and then let's see, what am I going to get? I think that's what it should look like. So fix that. All right, so what number was that, 65? What was the next one, 67? All right, what do you got for that one? Tony?
I had pi over 6 and 5 pi over 6.
Yes, that's what I got. 5 over 6 and 5 over 6. And then 67, 75. Emily?
0 and pi.
0 and pi, I got. All right, I do want to look at that one because I saw some mistakes or some question marks. What do we got there? Cosine squared minus sine squared equals 1. Cosine squared x minus sine squared x equals 1. Emily, what'd you do?
So I made cosine squared of x 1 minus sine squared of x.
Now, if you did it the other way, you still got to get the same answer. Your work will look slightly different. That gives me 1 minus 2 sine squared x. Because this doesn't work out typically how you expect it to work out. What do I got to do here? Or what can I do here? As you take a look at that one. Jacob?
Subtract the 1 over.
Subtract the 1 over, but what does that give me? I agree with you, but it gives me what?
2 sine squared x equals 0.
Yep, equals 0. I'm going to divide by -2. You can do that. So we get sine squared x equals 0. And then take your square root, square root of 0 is 0. So I just get sine of x equals 0. And if you think about that, and sometimes I think unit circle, sometimes I think graph. I mean, it just kind of depends on how your brain's wired. So if I think graph, where does it hit 0 at? It hits it at 0 right here, hits it at pi, hits it at 2 pi. But remember, we don't include 2 pi in our answers. It's not part of the interval. So 0 to pi, or you can think about unit circle where your y value is 0, which would also be 0 and pi for that one. All right, so it did get 0 and pi.
Did you do 42?
42? Yep. So 42 is, let's see, 42. Is it the sine of x plus pi over 4 equals, no?
No.
Not even close.
No.
Dang. Wait, what is, no, what is it, Aubrey?
2 cosine of x minus pi over 4 plus 1.
Plus 1
Yeah.
equals 0?
Yeah.
You know, whatever. I had a pi over 4. I got that right. I had a pi over 4 in it. Cosine x minus pi over 4 equals negative a half. Now, if there's anything other than the x, I'm doing substitution. So let theta equal x minus pi over 4. And so you're just saying cosine theta equals negative 1/2. Well, what two angles does the cosine equal negative 1/2? It's going to be quadrant 2, quadrant 3, reference angle is 60, so it's going to be what, 120 and 240, which is 2 pi over 3 and 4 pi over 3. So you get 2 pi over 3 and 4 pi over 3. And so now I come back and I got x minus pi over 4 equals 2 pi over 3. Add pi over 4. Oops. Add pi over 4. And 12, 8 plus 3. So yeah, it looks like 11 pi over 12. And this one is x minus pi over 4 equals 4 pi over 3. And then what do we get when we add pi over 4? Is that the 19? 19 pi over 12. So for that one, when you add that. Hey, a few of you missed 81. You should get, well, where did I put it? Pi over 3, 5 pi over 3, and pi. But 5 pi over 3 is thrown out because it doesn't work. Okay, the final answer is pi over 3 and pi, but you need to at least acknowledge you got that 5 pi over 3 and throw that out. You need to go back and look at, when you square both sides, you gotta make sure you foil. Make sure you foil for that, but these people miss that. All right, we're just gonna do a couple things here, then I'm gonna give you kind of a chapter 6 review to go over. To kind of get ready for the test. All right. On Thursday's test, what I'm gonna let you do is the right-hand side of the identity sheet. You can write that down on a separate sheet. Okay, the sum and difference, the double angle, half angle. You can have those written down on a separate sheet. You'll turn that in. Just looking at, I think last year's, it will be out of 100 points in the grade book, but the actual test might only be worth 80, just because it's just kind of how many problems there are and how much they're worth. So in the end, if you get, I don't know, 75 out of 80, I'll just make it 100 out of 100 in the grade book, which means take your percent, and I'll just put it in as like a 90. 3.8. Got it? I mean, I got to double check. I'm going to look at it again a little bit closer tonight. But it might only be out of 80 points, but I'm going to convert it to 100 because there's a lot in this chapter that does need to be worth 100 points. Okay, for that. All right, use your calculator. How can I graph this and solve that equation? How can you graph, using graphing, how can you solve that equation? Now, you might be better off keeping it in degrees just because you're more comfortable with that, so make it, think about how do you go graph that? And first of all, I want to ask you how many solutions there are. And then you're gonna see if you can figure out what they are.
Yeah. Maybe. Not sure. Oh, you could do graph.
It's teach you guys something. All right, I'm gonna make my window 0 to 360, just because that's the interval. Do I absolutely have to? No, but I'm gonna make it that. And what you can solve any equation by graphing, even if you have no idea how to go about it algebraically. All you gotta do is graph the left-hand side under one equation, graph the right-hand side on the other equation, and then see where they cross. Okay, you can always do that. So like you come across an ACT test and you got an equation, you have absolutely no idea what to do. Graph one side under Y1, graph the other under Y2, see where the heck they hit. So I got cosine of 2x and I got 0.5. Now some of you might have subtracted 1/2 and said it equals 0. You can do that, that's also fine. But that's what my graph looks like. Well, according to this, let's see, make sure you can interpret it correctly. How many solutions are there? More than 2. There's 4. What are you looking? So you gotta understand what you're looking for. When, let me do something here. Clear. 0.5. Okay. You graph the first one, you graph the second. What are we looking for? What happens? Where they hit. Those are your answers. That's where there's the same. That's the same. So how many times do they hit? Between 0 and 360, they hit 4 times. Now, if you wanted to find out the point, second, calculate, intersect, first curve, second curve. Now, this is where the guess comes into play. Because it hits 4 different times, right? You got to go over by where, at least for the first one, it says 30. 30 what? 30 degrees. That's your first answer. All right. And then you would have to hit second, calculate, intersect, first curve, which is the cosine, second curve, which is the 1/2, and guess. Now I got to go over here. And I just got to get somewhere close to it. 150. So we see the 4 answers, right? At least graphically, we got that figured out. All right, how do we find them out algebraically? Okay, how do you find them out algebraically? And I just want to go through this case here. All right, let's solve it like we normally would. But what do I tell you to do? Now, those of you who did those trick mazes at the end, you kind of did some substitution, or you did some identity work. I'm not going to do that. Okay, that may work, it may not. I don't even know. But if I have something other than x, what do I always tell you to do? Substitution. So I'm going to use let theta equal 2x. If you got something other than x, that means some things have been shifted or moved around, which means you could get the answers in different spots. If it's just an x in there, you're going to get those two answers like normal. You don't need to worry about anything. But if I got something other than that, I'm going to do this, and I get cosine of theta equals 1/2. All right, well, where does that work at? Cosine theta equals 1/2 at pi over 3 and what else? 5 pi over 3. Okay, so I'm going to do theta equals pi over 3. Now, since things have changed, I'm actually going to put plus 2 pi n. And then I'm going to put over here theta equals 5 pi over 3 plus 2 pi n. Only when there's something other than an x, because I could have more than one answer, more than two answers. Now theta got replaced by what? 2x. So put 2x equals pi over 3 plus 2 pi n. And then theta equals, or 2x equals 5 pi over 3 plus 2 pi n. All right, what do I got to do? I got to divide by what? For both of them, got to divide by 2. So divide everything by 2. And I get x equals pi over 6 plus pi n. And then I get x equals 5 pi over 6 plus pi n. Okay. Well, how do I go about finding those four answers? We already saw them. How do I go about finding them at this point? That's the general form. That lists all solutions. We don't want all solutions, right? We only want the solutions from 0 to where? 2 pi. But since I got something other than the x in there, I could have more or less. So what you want to do is you just want to let n equal 0 and then see what happens. Well, if you let n equal 0, what does this give me over here? Pi over 6, right? Which would be 30. So you get pi over 6. Whoa, I don't like that. And then what do I get over here? If n equals 0, I get 5 pi over 6. Then let n equal 1. You're letting n equal 1 back up here, which means pi over 6 plus pi. Well, what is that? 7 pi over 6. 7 pi. Is that still less than 2 pi? Yep. 7 pi over 6, and then I get, what's 5 pi over 6 plus pi over 6? That should be 11 pi over 6. Now, we figured out there's how many answers. We already know there's how many answers. 4. How many answers do I have? 4. But just amuse me here. What would you keep doing if you didn't know that? You would let n equal what? 2. So we keep going until we get something outside of our range. So n equals 2. And what do I get when n equals 2? Okay, right there, that becomes pi over 6. Plus 2 pi, which gives me 13 pi over 6, which is too big. Okay, so we don't need to keep going anymore. So we got those 4 answers. So the 4 answers were pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Because hopefully when you think about this, what does the 2 do to the equation? Just, we know from transformations, the 2 is going to be a horizontal what? Compression. That's why we get more than 2 answers. So if something like this comes up, you can't say just the answer is pi over 3 and 5 pi over 3. You got to take into account, and plus we're going to have additional answers for that. All right, I want to take a look at one more. I know it says 3, but we'll make it a 2. Cosine of x minus sine of 2x equals 0. Now, I can't necessarily do what I just did on that last one because I got another cosine of x. So you want to take identities and try to get it in both in terms of just x. Well, go to your identity sheet. What's sine of 2x equal? Figure.
2 sine of x, cosine of x.
2 sine of x, cosine of x. So I'm going to put that over here. And actually, I get sine 2x equals 2 sine of x times cosine of x. So I got cosine of x minus, bless you, 2 sine of x times cosine of x equals 0. All right, we can solve it from here. There's really one little step I got to do, but sometimes you just overlook it. All right, take a second, look at it. Jacob, give everybody a chance here, and I'll give you the first crack at it. We'll wait for Lane, see what he can figure out. All right, Jacob, what do you think?
Head over the 2 sine of x, cosine of x,
And then where are you going with there? Because I don't think you have to do that. I think I can do it without that.
divided by cosine of x.
Okay, one thing you don't want to do is divide by a cos, because what that does is eliminate potential answer. Okay, so there's something we do instead of dividing. That'll give you like half the answers. Okay, Adam?
Factor it out.
You want to factor it out. So when you see that situation, you think, hey, if I divide by this, it'll reduce it. Think factor first. So factor out the cosine of x. Before you do that. Because now once it's factored, once you do the zero product property, you can set each equal to 0. Because if you divide by that cosine, then you lose this answer right here. So cosine x equals 0. 1 minus 2 sine of x equals 0. Well, where's cosine equals 0 at? That's going to be at pi over 2 and 3 pi over 2. Okay, 90 degrees and 270. And what do I get here? 1 equals 2 sine of x. Sine of x equals 1/2, which gives me pi over 6. 5 pi over 6. Okay, for that. And then technically I should list them all together. Pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. All right. All right, what I want to do is give you a chapter 6 review sheet. Work on this for the rest of the period. We'll go over it tomorrow as well as a couple other things. There will be one identity for sure on the test. No proof.
We have room on the paper. I could have made that. Is this the homework? There's no homework.
Oh, is that
Okay.
the identity? He just went, he looked at the identity sheet, and so sign 2, sign 2x is the same as 2 signs. So he just, I don't know why they equal each other, but that's how he got it. So he just looked at the identity sheet and guessed that.
Wait, is this the really complicated
guess
way,
so.
or is this the simple?
This is
It's
also-
the one where it's
That's the
like,
exact same thing.
it's more
I'll come back.
flexible.
I forgot. We're gonna- Oh, dude.
Right, it's just so hard.
No.
I know you're good. I was like, maybe right now, I was thinking.
Oh,
Yes, you said
God.
identity, but I guess it was
Plus 45 equals
formula.
Yeah, 700.
Oh my gosh, that's right.
And then, I know.
Are you telling me?
Okay, I'll tell you now, go ahead and skip 13. 13 is similar to the one we did here, where we did the n equals 1, n equals 2. I'm not gonna put anything like that on the test. I wanted to show it to you for when it comes up, but I'm not gonna test you over it. So skip 13. And you may work together, that is fine.
Over 3.